The objective of this experiment is to calibrate a light-dependent resistor by establishing a relationship between its resistance and distance of light. Additionally, the experiment aims to measure the sensitivity of the LDR by determining the change in resistance for a given change in distance of light. Our experimental setup involved connecting the LDR to an Arduino board, which was then connected to a computer. A 240-volt bulb served as our light source, and a ruler was used to accurately measure the distance between the bulb and the LDR. The Arduino was used to read the output voltage from the LDR circuit, which was then converted to resistance values. This experiment effectively calibrates the LDR by determining the relation between its resistance and the distance of the light. With the calculation of the change in resistance for a change in the distance of light, we can also calculate the sensitivity of the LDR using the experiment. The resistance that rises with the light's distance from the LDR is what the LDR measures due to the LDR increased resistance. This reaction also shows that the quantity of light reduces with higher distance between the lights. The readings were found to raise the resistance of the LDR from 1.6 kilo ohm to 2.25 kilo ohm when the distance between the light and LDR was raised from 14 cm to 23 cm. From the graph, we can observe that there is a very constant and smooth gradient for all the points. We can see how the LDR responds to its distance away from the light and are able to calculate its sensitivity from this graph. The resistance increased by about 111 ohms per centimeter of length, and the sensitivity was about 0.111 kilo ohm per centimeter. The fact that it keeps changing demonstrates how the LDR can indeed detect very small changes in light intensity. However, there is a certain nonlinearity caused by some extraneous variables such as problem with alignment, bad light, and variation in the intensity of light. This issue, however, does not significantly affect the validity of the result since the general pattern is repeatable and consistent. For data acquisition and analysis, we utilize LabVIEW software. The block diagram of our LabVIEW illustrates how we interface with the Arduino to continuously read data, process it, and display it likely on a waveform chart. This integration helps in real-time monitoring and data collection during the experiment. Last but not least, the experiment showed that the light-dependent resistor LDR works well and is sensitive to light. It confirmed that the LDR resistance increases when light decreases, showing an inverse linear relationship with distance. Sensitivity was measured at 0.111 kilo ohm per centimeter, proving the LDR is highly responsive to light changes. These results suggest that LDR can be used in real-life systems that detect light levels. The consistent data and calibration curve also show the sensor is accurate and reliable.